All right, we're going to finish up 3-4. Call it B. Actually, we're not finishing up 3-4. We're only finishing a third of what this lesson is all about. Remember, we're going to do three things. First thing, we're going to do distance. And then I think the next thing is midpoint. We're not going to do that today. We'll do that probably Monday or Tuesday. We'll do midpoint, and then we're going to do slope. Okay? Everybody hear me? Yes, yesterday was A. Oops, forgot. All right, let me hook up my mic. Forgot to do that. That probably sounds better. All right, so let's do this. So what did we talk about yesterday? We said the distance. We'll just go real basic here, what we did yesterday. So remember we had the car. We were here. We were here. I don't know what numbers we used. Let's just use 3 and 10. Let's use something else. Let's use 10 or 2 and 8, okay? So if I ask you to find the distance, find the distance, it basically means find the length of that line right there, that line segment. It starts and stops. It's not a line because a line does what? Keeps doing what? Keeps going. But this is a line what? A line what? Segments. A line segment, okay? So we're trying to find the length of it, the distance, okay? They both basically mean the same thing. You could just sit here and put some marks on here and count, all right? But we don't want to do that, all right? So what do? What math do we do? Simple math. You probably could do this in like, I don't know, 5th grade or something like that. If I said, how far is it from here to here? So how would you do it? How'd you get 6? It's 8 minus 2. That's right. Okay, so it's 8 minus 2. So what'd you do? You subtracted, correct? But remember the last thing we talked about yesterday. Actually, let's grab this right here. So we're not just going to go along one direction. We took a lot of time yesterday to talk about this thing. What do we call this graph thing? Or what's like a special name for it? Look in your notes. I gave you 2 different names for it. Give me one of them. What? Descartes. How do you... Well, quadrant's part of it. What do we call the whole entire thing? A coordinate plane. Okay, we call it a coordinate plane, or it's named after some guy with a girl's name. Cartesian. Rene, right? Rene Descartes. But we call it the Cartesian plane. Now, when I say a girl's name in France, it's not a girl's name. All right. So, but here we probably think of Rene as being a girl, but it could definitely be a boy as well. All right. So what we're going to do is we're going to put a couple points here. Let's just put a point. Let's use a different color here so it doesn't blend in. So let's put a point right here. Just picking a couple random points. All right. We'll put a point about right there. And then I'm going to connect those 2 points. And the whole idea of what we're doing today is to find the length of that line. Find the length of that yellow line. Okay? Now I'm going to do something that's kind of weird, this first part, so just bear with me, pay attention. All right? I had considered not doing this, but you guys have been paying attention fairly well recently, so I think you might be able to handle this. We'll see. So I'm going to call this point. Now, it is on a graph. All right, so I could find exactly where that point is. But let's just say it's some random point. I don't really know where it is. So let's call it something. I don't know if we did this yesterday or not. So what are the coordinates? You go over x, you go over y, correct? All right, so I'll call this xy. But watch what I'm going to do. I want to also call this xy. But if this is x and this is x, that's not the same x, is it? So what I'm going to do is I'm going to differentiate a little bit. I'm going to make it just a little bit different. I'm going to call this is my first point, all right? So I'm going to call this x1. And what do you think I'll call the y? y1, okay? So this is my first point. This is my second point. So I would call this x what? 2 and y2. This doesn't mean squared, doesn't mean times. It's just a number to make it different, right? Make this x different than this x. Is that all right? So instead of calling this z or a or b or c or something like that, I call this one x1, I call this one x2. Got it? I call this one y1, I call this one y2. That's the only thing different. Everybody okay with that? All right. So now, what I want to do is I want to do something that let's do this. I'm trying to think of where I want to go with this. Remember, we can't just count. Remember we did something like this on a graph yesterday. We went straight across, and I could have just counted, right? So I'm not going to do that here because I can't, because I don't know, like from there to there, is that 1 from there to there? No, it's not, because that's like at a diagonal, okay? It's not exactly one of these little blocks. So I can't just sit there and go 1, 2, 3, 4, 5 to count how far that is. So what I can do is this. I'll do this in different colors, all right? What I can do is start here and count over to there, okay? And then let's get rid of that. And then let's do another color just to make them different. And then I could go from here up to here. Everybody see that? All right. Now, this is going to be kind of weird, but I just want you to think about it. Where is this point? If this is x1 and y1, and this is x2 and y2, what do you think that point's going to be? Well, you'd think we could just say x3 and y3, okay? And that would be, it wouldn't be wrong, okay? But I want it to have an x1 or an x2 in it. I want to have a y1 or a y2 in it. So, for instance, how did I get to this point right here? I started at the origin. How far over did I go to get to that point up there? Well, don't count. Okay, don't count the little things. And it wouldn't be 11 anyway, but no. I mean, look, from the origin to right here, that's not 11. It's what? 1, 2, 3, 4, 5, 6 over. But forget the grid marks, okay? Forget the numbers. As far as x1 or x2 goes, how far over did I go from here to here? No, forget numbers. We're not using regular numbers. It's either x1 or x2. How far over did I go from here to here? x1's down here, though. I went over x2, didn't I? You see that? Because look, how did I get to this point? I went over this far, and I went up this far. Okay? So how far over did I go? I've got my point. So how far over did I go? I went over x2. You're not getting this, are you? All right. I'll tell you what. I'm just going to skim through this, and you don't have to get it, all right? That's why I debated whether I should do this or not, because it is a little complicated. It's a little weird. Even in my honors class, they're looking at me real funny. They're like, what in the world? And then eventually they started getting the hang of it, but it's a tough concept. So let's just forget about that. I'll just explain it very quickly. So in order to go over here, it's the same, and to get up to this point, it's the same distance over. For instance, let's use the grid marks right now. So I'm not going to give up on you. All right, so what would this point be if I use the grid marks? We went over 6 and we went up how many? 3. So what is the x2? The x2 is what? 6. What is the y2? It's 3. Everybody with me on that? Okay, so what's this point right here? How far over did we go? Just number-wise. We went over 6. The same as x2, right? So instead of saying I went over 6, what could I put here? X what? X2. You see that? Okay, so I went over 6 and I went down a certain number. Agreed? But I did go over 6. I went over 6 to get up to here. Look, any point that lies along this line right here, I went over 6. But instead of saying 6, I want to be real general. Instead of saying 6, what do I say? I went over x2. So this point right here, how far over did I go before I went down? I went over x2. All right? If you don't get it, it's no big deal. This won't exactly be on the quiz or test, all right? So don't worry too much about it. Now, what about this point down here? How far down did I go to get to this? I went y1. So how far down do I go to get to this point right here? No, look at the distance. I went down y1. I went down from here to here. How far did I go down to here to here? Neil, say it. I went y1. All right. If you don't get it, it's no big deal. Don't worry about it. Okay. So, but just know that this point right here is x2, y2. All right. I think that's important that you know that. Let's scooch this over a little bit. Let's put it over here. All right, use this area to write. Now, here's something that I don't know if you remember or if you ever studied in Algebra 1. It should have been, but I don't know, maybe not every Algebra 1 class teaches it. What I need to do, because I say this, what'd I do? I say this every time, and I really should look at an Algebra 1 book and see if they actually do teach this in Algebra 1. But I'm going to teach it to you right now, okay? Here's a triangle, and I put this little box there. I think we've already talked about that in here, haven't we? What's that little box indicate? It's a right angle. How many degrees? 90 degrees. So what kind of triangle is this? It's a right triangle, right? We've talked about right triangles, haven't we? Yeah, because we talked about acute and obtuse and right triangles. Yeah. Here's something that I don't know if you've seen before. Let's call this side right here A. Let's call this side right here B. And then we'll call this. Now, this side right here has a special name. It's opposite the right angle. I don't know if we talked about this earlier or not, but you might have learned it in another course, maybe in middle school when you did some regular math stuff. Anybody remember the name of the side that's opposite the right angle? Starts with an H. Did you say it? Hypotenuse. Very good. Who said that? Judy said that? All right, good. It's the hypotenuse. See? He came out of nowhere with that. It's called the hypotenuse. Right. He just likes the pot part of it, I guess. Okay, whatever. Whatever gets you through. All right, so that's the hypotenuse. All right, so we'll call, this is the leg of the right triangle, and so is this. A right triangle's got two legs. The two legs are the ones that are not the hypotenuse, okay? And the hypotenuse is always opposite what? The right angle. The hypotenuse is always opposite the right angle. It's really important. So if I call this leg A, this leg B, what do you think I'm going to call a hypotenuse? C. All right, so A, B, and C. Just makes it easy. I could have used any letters, but most of the time when we study this thing, we use A, B, and C. Now, there's a little theorem. All right, there's a theorem. It can be proven. We're not going to do it because it's actually very difficult to prove. And it's actually named for a guy, an old guy, way older than Descartes. Descartes was like, what, late 1500s, early 1600s, right? Isn't that what I said? I forget. So this guy goes way back before Christ. In fact, I think, I'm not positive, but I think several hundred years before Christ. This guy goes way back, Old Testament way back, all right? And this guy's name was Pythagoras. Pythagoras. I don't know, guys back then, it just seems like they had one name, right? You read the Bible, you had David, right? You had Jonathan, you had whatever, King Nebuchadnezzar, and that was it, whatever. Abraham, Isaac, right? They all had just one name, it seems like. Maybe they had two names back then, they just didn't put it in the Bible. I have no idea. All right, but this guy's name was Pythagoras. Yeah, mine. It is. That's exactly what we're going to do. All right. So this guy's name is Pythagoras. He didn't really come up with this. They actually knew what I'm going to show you in a second. They actually knew what this was way before Pythagoras. Okay. So this theorem that I'm going to show you is literally thousands of years old. Everybody hear me? It's literally thousands of years old. So it's not something new that just came up, a few years ago. This is thousands of years old. All right, and it hasn't changed, and it's true. All right, but this guy didn't come up with it. This guy actually proved it. He was able to prove that what we're going to show you is true, and it took hundreds, maybe even several thousand years before somebody could actually have a good proof of it, and that's why they give him the name. That's why they give him the name of this theorem, and I'm going to tell you the name of the theorem. Then I'm going to show you what the theorem is. So his name is Pythagoras, but we call it the Pythagorean theorem. It's one of the most famous theorems in all of geometry, really in all of math. Okay, it's probably one of the most famous theorems that you'll ever learn. And it's called the Pythagorean theorem. Who's heard or studied the Pythagorean theorem? I've got a couple of you. Where did you study? Were you here last year? What school did you go to? You went where? Oh, where's that? It's not around here, is it? Where is it? Oh, Exton. Okay. So anyway, so this should have been, I think, I'm not 100% sure, but I think it should have been taught in Algebra 1. All right. Did you take Algebra 1 last year? And they taught it in Algebra 1? Yeah, I figured it would be. Okay. There's no eating. There's no eating. Well, maybe you didn't allow the teacher last year to get this far. That's my guess. Okay, so Pythagorean theorem. Here it is. The Pythagorean, listen to what I'm saying. This first thing, listen. This is what I tell people. The Pythagorean theorem is easy. It's as easy as A, B, C. All right, it's as easy as A, B, C. All right, here it is. You ready? A squared plus B squared equals C squared. There it is right there. It's something that's been known for thousands of years, and it took somebody several thousand years back to be able to prove that this was true, but people have used this, okay? You use this all the time. When you build buildings, there's right angles all over the place in buildings, aren't there? All right, so there's going to be a hypotenuse. If there's right angles, there's going to be a hypotenuse, right? So this has hypotenuse, and it's got a couple legs. Excuse me. There we go. Am I? Yes.
So how we make, if this ABC is AB squared, ABC, that means we move to the right.
I'll show you how to do it in a second, okay? All right, so here we go. Everybody watching? Everybody watching? So what if I had a triangle? Let's do this. This is probably the easiest right triangle that we'll do. This all is going to lead us up to this distance formula. All this has to do with the distance formula. I'm not taking you on some kind of rabbit trail or anything like that. Okay? So what if the length of this leg right here was 3 and the length of this leg right here was 4? What I want to do, sorry about that. Gotta let my cough drop. Take some action here. All right. So what if I want to solve for C? This is a perfect situation. This is probably the easiest situation that you'll ever encounter with Pythagorean theorem. Yes. It's 4. So you think this length right here is the same as this length right there? Really? Because what if this was on like a little pivot? No. Pretend this was like a board. This would come and it would land right here, wouldn't it? So it would be longer than 4, wouldn't it? Would you agree? 7? All right, well, let's do the math. This is why we have the Pythagorean theorem. Let's use this. Man, I need a drink or something. A bath? I don't need a bath. A bed? A bev. Oh, okay. It's like, how's that going to help I could use a bath, but... All right. Here's what we're going to do. We're going to plug the stuff in and we're going to solve for it. So, what is the A? The 3. And it actually doesn't matter. It doesn't matter which one the A and the B is. Okay? So, you could have made the A the 4. You could have made the A the 3. These are your legs. The A and the B are either one of the legs. And again, it doesn't matter which one. But the C is always the what? The hypotenuse. I'll just put HYP for hypotenuse. Okay? That's important to know. The A and the B are always the legs. The C is always the hypotenuse. That's super important. Hope you guys are paying attention. I got a couple that aren't. They're having their own conversation back there. They don't even hear me talking. Okay, thank you. So, what am I going to put in for A? You could put 3 or 4. It doesn't make any difference. Let's just use the 3. And what are we going to do with that A, though? We're going to do what to it? We're going to square it, according to this theorem. Okay? And then we're going to put what? Plus, right? Because that plus. Then we're going to take the other one. What's the other one that we didn't use? The 4. And we're going to square that. What's that? C is the hypotenuse. And we don't know the hypotenuse. That's what we're trying to find. Okay? We're trying to solve for the hypotenuse. You with me so far? All right. So the A and the B are the legs. So they tell me both of the legs, right? They tell me one is 3 and they tell me the other is 4. So I square them both and set it equal to what? C squared. Good.
Oh.
Now what I'm going to do is do a little bit of algebra, okay? Like we always do in geometry, right? We set up the geometry and then we do algebra, all right? So 3 squared is what? 9. Plus 4 squared is 16. And what's that equal? That equals C squared. Is that next door? It's like that all day long. It really is. It's crazy. All right, I'm not going to say anything because I'm online, so I'm not going to say anything because we're online. All right, so 9 plus 16. What's 9 plus 16? It's 25. It's not 26. 10 plus 16 would be 26, right? Take one away from it, that's 25. And that equals C squared. Now, here's a spot right here where you might get a little stuck. What do you do when you square something?
You divide it by 2.
What?
So you divide it by 2
You divide
Look.
it by itself.
Look, how did we get 9 out of 3 squared? You multiply it by itself. Not twice, just you multiply by itself, okay? So watch. Listen. So 3 squared, from here to here, I kind of assumed that you already knew how to do that, but apparently half of us didn't, so I'm going to go through it. So watch. 3 squared means you take that number, that base, the big number on the bottom, you multiply it by itself. Everybody hear me? Multiply it by itself. You don't multiply by 2. This is not 3 times 2. Is 3 times 2 9? Is 4 times 2 16? No. So you don't multiply it by 2. You multiply it by, say it again, multiply it by itself. Itself. You with me? All right. So what does C squared mean? It means what number multiplied by itself is going to equal 25. 1 times 1 is 25. What number times itself is going to be 25? 5. Because 5 times 5 times itself, right? 5 times 5 is what? 5 times 5 is what? 25, okay? So look at this. This says, let's pay attention. So I can tell when things start getting a little bit tougher, that's when you start talking because you don't understand. That's the time you should not talk. That's the one time you shouldn't talk, is when you don't understand it. So let's pay attention. So this says right here, what number? C, right? What number? C times itself. That's what squared means. What number times itself is going to give you 25? Well, 5 is, all right? So C equals what? 5. Everybody with me? So what's the length of this third side right here? It's 5. So this is what we call a 3, 4, 5 right triangle. It's a very special triangle. It's something that we're going to do later on, maybe, if we get there, okay? And towards the end of the book, we're going to be doing some stuff with 3, 4, 5 triangles, 3, 4, 5 right triangles, okay? It's a very, very common, it's a very special triangle that we use a lot. Not every triangle is going to be a 3, 4, 5 triangle. There's just this one kind of special one, all right? Let me show you something else before we move on. I was trying to get you to think what number times itself is 25. So what if we had this? What if I had 49 equals C squared? What would C be equal to there? It'd be 7, because 7 times 7 times itself, right? 7 times 7 is 49. What if I had 100 equals C squared? What is C? It's 10. It's not half. We're not taking half. Did we take half of 49? Did we? No.
And I knew that. So
Okay. All right. So we're not, but that's a common mistake. All right. That's why I pointed it out, because it's a common mistake that people make. They think, oh, we just take half of it. No, it's not half. It's what number times itself is equal to 100. Well, 10. 10 times 10 is 100. 7 times 7 is 49. 3 times 3 is 9. Okay? Everybody with me? What's another way I could do this? How do I get from 49 to 7? How do I get from 9 to 3? How do I get from 16 to 4? How do I get from 25 to 5? Not dividing it.
Multiplying.
Nope. What's the opposite of squaring something?
Unscrewing.
It's not bad. Not a bad idea if you didn't know what it was. Say it. Square root. Have you heard of square roots?
Yes, I can do that.
Okay, let's go through it. I feel like I'm teaching more of an Algebra 1 class in here than I'm teaching geometry, but that's okay. We need to learn it. Everybody look up here. Watch this. What is the square root of 36? It's 6. Why is it 6? It's not half. Listen to me. Apparently, that's why I stopped a lot, Nigeria, because you were talking a whole bunch, and while you were talking, I had a conversation up here that said we're not taking half of it. This is not half. This is what? What number times itself, right? It's a square root, which means what number times itself is equal to that number. It's 6. It's not 18.
I'm sorry, my mean is
What if I had this? What's the square root of 4?
2.
This is 2. Now, some of you might say, well, Mr. Hamrick, I thought you didn't take half of it. You take half of 4, it's 2. But this is the one situation where if you do take half of it, it comes out to the same thing as the square root. All right, I'm trying to think of some other numbers I haven't used yet. Let's do this. Square root of 64. What's the square root of 64? It's 8. Okay, getting the hang of this? All right. Now, let's go back to this. What did I just say about the square root? It's the opposite of doing what? No. Squaring something. It's the opposite of squaring something. So look here. I want to get c by itself. I don't want c squared. I just want c. So how do I get rid of something? I always do the opposite. What's the opposite of squaring? That's fine. I square it. I square root it. I square root it. Everybody look up here. Jump up here. It's not helping you. So what's the opposite of squaring something? Taking the what? Square root of it. So what happens when you do the opposite of something? It gets rid of it, doesn't it? All right. So in algebra, if I do something to one side, I also have to do what? To the other side. All right. So look what I get. That square root and that square cancel each other out. So c equals the square root of 25. What's the square root of 25? It's just 5. So I could write it a little nicer. C equals 5. Does that make sense? Okay. So I want to get c by itself. How do I do it? I do the opposite of what's happening here. This is being squared. What's the opposite of squaring something? Taking the square root. So I take the square root of this side. I take the square root of the other side. The square root and the squares are opposites of each other, so they cancel out. What's the square root of 25? It's 5. That's my answer. Okay? What if we add something like this? Watch this. Let's get rid of all this mess. Okay. I'm making up a random thing here, okay? So what if this is 2 and this is 3? What is that? Is it going to be 2, 3, 4? Because we did 3, 4, 5. This looks like it's going to be 2, 3, 4, doesn't it? It's not. All right? So what do? This is a C, by the way. All right? So what do? We use the what? What's the theorem called? Pythagorean theorem. So it's a squared plus b squared equals c squared. So what's the a? 2. So we're going to 2 and squared. Plus b squared. What's the b? 3. Now again, it doesn't matter. You could have called the a 3 and you could have called the b 2. It doesn't make any difference. But what does make a difference is you call the c, and it's there by itself. Okay? It's the hypotenuse. But you got to square it, don't you? So let's do this. What do we get? What's 2 squared? 4. Plus, what's 3 squared? It's not 6. It's 9. It's multiplied by itself. 3 times 3. That's a 9. And that equals what? C squared. 4 and 9 is 13. That equals c squared. Now, what do I do to get c by itself? So this side right here is not 13. Okay? How do I get rid of that squared? Square root it. Square root this side. Then what do I do to the other side? Square root this side. Now, everybody listen. What number times itself is equal to 13? Well, there's no whole number, is there? No, there's no whole number. So, guess what we're going to do? Nope. we're just going to keep it the square root of 13. We're just going to keep it like that. Here, let's pull out a calculator. I got a calculator right here. Have I ever shown you my calculator before? Isn't that cool? This won't show up on, I got to click on my keyboard. This won't show up on YouTube, but I got this calculator, and so there we go. So what am I going to do? Square root. Do you see the square root button right there? It's kind of little. It's yellow. So if it's yellow, what would I do? Hit the second function. Hit that. See the square root? Okay, and then I put 13. You could close the parentheses. You don't have to. The square root of 13. I don't know. Somebody take a wild guess. What do you think the square, between what and what?
5 and 6.
Okay, so 5 point something. Anybody else? 0 or 1, between 0 and 1. Anybody else?
Hit you with the blade.
I don't even know what it is off the top of my head, but I can tell you right now, it's somewhere between 3 and 4. How do I know it? It's not because I'm super smart. It's not, okay? It's not because I'm the teacher. Why? John, what are you doing?
I get 3.6.
Why is it between 3 and 4? Because look, because 13 is between 9 and 16. Why did I pick 9 and 16? That's weird. Why did I pick 9 and 16? Because the square root of 9 is what? 3. And the square root of 16 is what? 4. Where does 13 lie? Somewhere in between. Agreed? So the square root of 13's got to be somewhere between 3 and 4. So there it is. All right? There it is, 3.6. All right? Now, what do I want as an answer? I don't want 3.6. I don't want you putting it into a calculator. All I want you to do is just circle it, and then you're done. That's your answer. It's a square root of 13. So C is equal to the square root of 13. That seems kind of weird. You're like, well, what does that mean? Well, what it means is it's 3.6. It's a little bit longer than this side right here. You see that? That's what it means. It's approximately 3.6. But the square root of 13 is an actual exact number is what I'm trying to think of. All right, let's get rid of that calculator. Now, let's finally get to what we were trying to do over here. Now, all that to lead up to this. I'm trying just to click the pink one. That's all right. I'll just come up here and just make this pink. All right, so here we go. Watch. Everybody look. All that. We got 5 minutes, so you got to pay attention. Stick with me. I know we've been doing a lot today. It's gone on a little longer than normal, so just pay attention. What I'm trying to do is this. Why did I go through that whole Pythagorean theorem thing? Because what kind of triangle is this? It's a right triangle, okay? And this would be my A, the pink one would be the A, and the blue one would be the B, or vice versa, doesn't matter. What would the yellow one be? The yellow one would be the C, right? And that's what I'm trying to find, isn't it? So what I can do, I can find this distance from here to here. How do I find that distance? I subtract the x's, correct? So watch very carefully. So I subtract the x's. A lot of times the books will go x2 minus x1. It does not matter what order you subtract them in. I could have gone the first one minus the second one or the second one minus the first one. It doesn't make any difference. Okay? So that's the pink one. What about, see if I can grab the blue. What's this distance from one point to the other on the y-axis? It's y2 minus what? y1. So now, look what we're going to do. This distance. Now, we had been calling it C because Pythagorean theorem uses A, B, and C, but it's distance, so guess what letter I'm going to use instead of C? D, all right? Should have made that yellow, but that's okay. All right, so we're going to call this D. So now watch carefully. This is it. That we're finally here, all right? Put the yearbook away. I won't call a name, but somebody put the yearbook away. Put the yearbook away. That's not going to help you learn this stuff. Now watch. If you've been following along at all, I don't know if you have, but if you have, let's change this back to white. Now take a look. This right here is the A. This is the b. You with me? So I'm going to put distance squared is equal to, I put it on the left-hand side instead of the right. Is that okay with you? So instead of equals c squared, I put it on the left-hand side. So what's my a? I just circled it. What's the a? That's the a. So what is it? Come on, let's think. What's the a? I circled it, I put an a next to it and an arrow. What's the a? It's x what? x2 minus x1. All right? I'm getting a little frustrated because I made it super easy for you. Okay, I circled it, even put an a. I said, what's the a? It's x2 minus x1. Now, in Pythagorean theorem, what do we do with this? We square it, don't we? Now, what's the b? This is the b right here. That's the b. My writing is terrible. So what's the b? It's y2 minus y1. And what do we do with that? We square it. That thing that I just gave you right there, guess what that is? The answer. There's no answer. There's no question. What is this? This is the distance. What's the name of this lesson? Thank you. It's the distance formula. It looks confusing. It kind of looks like slope. This is your distance formula. Guess what you're going to have to do with this? You got to memorize it. Okay? There's no way around it. I don't care. I'm not going to give it to you. Listen to me. Listen to me. I am not going to give it to you on a quiz. I'm not going to give it to you on a test. You must memorize the distance formula. Let's do an example. I'll show you how to use it. It's a lot easier to use than it is what we just went through. We went through a lot of stuff. Looking back on it, maybe I should have just jumped right to this. But I don't know. I just feel like as a teacher, I would feel inadequate if I didn't show you where it came from. So, do you have it memorized yet? D squared equals what? Yeah, x2 minus x, it's not squared. It's x2. x2 minus x1 squared plus y2 minus y1 what? Squared. Here's another way you might see it. Everybody watch this. Instead of writing d squared, how could I get rid of that squared right there? I could do what? I could square root it, couldn't I? But then I'd have to square root this whole entire side. Why are they getting out early? So watch. Come on, you guys. You guys have done half decent today, but now you're losing it. Just give me a couple minutes here. All right? So this is how you're actually going to see it in the book. Okay? When you see the distance formula in a book, this is how you're going to see it. All right? So you're going to see a big old square root, and then x2 minus x1 squared plus y2 minus y1 squared. That's the formula right there. This is really what you should memorize, to tell you the truth. But if you memorize the other one, you can still get to this. Let's do a problem. Here's what they're going to give you. Are you ready to do a problem? It says, find the distance. Wish I had a couple more minutes, but I'll try to squeeze it in. Find the distance between these 2 points. Everybody look. Please, have a little stamina, all right? Have a little bit. Oops. Get a pen to write here. John, please stop. All right, here we go. Here's my 2 points. So which ones are my x's? Well, that's an x1, and this is a y1. This is a what? x2, and this one's a y2. So now all we do is plug it into the formula. So distance equals big old square root. Anybody writing this down? See, a handful of you. Not everybody. So what I'm going to do, this is what I call the shell of the formula. Okay? I put the square root, the parentheses, the squared. The bell's going to ring in a second, but hang on for just a few minutes, okay? Or a minute, 1 minute, okay? So look, what do I put in here? x2 minus x1. So I said, hang on a minute. I said, the bell's going to ring. Hang on a minute. Sit down. Sit down. You guys need to tell him to sit down because we are not going to leave unless everybody's seated. I already warned you to stay seated when the bell rings. I don't care. So watch. You better talk to your boy right here because I'm telling you, listen, if I know, but he keeps on mouthing off to me. All right, he needs to stop.
Just eat a ball.
So 5.
That's like saying I'm late to his class.
Everybody look.
Stop, guys.
We would have been done if you would just be quiet and listen to me. So look, write this down, then look at it when you get home. Okay? What's negative 6 squared? It's 36. What's 4 squared? It's 16. Take the square root, okay, and then you get 52. That is your answer. Here's what you're doing. You're doing numbers 1 through 6 on section, whatever section this is. What is it? 3-4. Section 3-4.
Stop trying to hit.
That's homework. This is homework. No, this is in your book. This is all in your book.